Hello and welcome to your latest Maths Wizard video. Today we're going to be taking a look at angles in triangles. So by the end of this video you should know the angle rules for triangles and you should be able to calculate the size of some missing angles inside triangles. So the first rule that we're going to mention is that the interior angles inside any triangle, doesn't matter which type of triangle it is, always add up to 180 degrees. So that's the same for equilateral triangles. So this is a triangle where all of the sides are equal. It's the same for isosceles triangles. So this is a triangle where you've got two equal sides and one side that is a different length. And scalene triangles where all of the sides are different lengths. So whatever the triangle is, and we've also got as well right angle triangles, whatever the triangle is, the angles will always add up to 180 degrees. Okay, now inside an equilateral triangle, all of the angles are equal. So they add up to 180, but if you take that 180, you can divide it equally by 3. So each angle will be 60 degrees for that one. The key thing to remember with isosceles triangle is this, that the base angles in an isosceles triangle, so it's got to be the angles that are at the base of the two equal sides, or at the bottom of the two equal sides. So just be really careful if you get an isosceles triangle drawn in a different way. So it's got to be these two angles on this one I've just drawn there. It's got to be the two angles at the bottom of the two equal sides that will be the same size. So that was your angle rule sorted. So now we're going to have a look at a few examples of some questions where you can apply those rules. So first question, just got an isosceles triangle there. So let's see if you've remembered how big each angle is. So pause your video, have a go. Okay, so like I've said, they all add up to 180. We've got three angles that are the same. So each angle will be 60 degrees. Okay, next one then we've got what are the sizes of angles D and E on this particular triangle? So how big are angles D and E? So pause your video and have a go. Okay, let's take a look then. So we know that one of the angles is 50 degrees, and these lines here indicate that this is an isosceles triangle. So if we take that 50 away from 180, you get 130 degrees. So these two angles are at the base, so they're going to be equal. So you can divide that by 2 and you'll get 65 degrees. So each angle at the base of that isosceles triangle will be 65 degrees. Okay, next one then, I want you to work out the size of angle X, just at the bottom here. So angle X on this triangle. Okay, so if we look at the ones we've already got, if we add those together, so we've got 132 degrees already there. So if we take that 180 away from 132 degrees, we're going to get 48 for the remaining angle on this scalene triangle. Okay, we've got a slightly more complicated example. This is taken from a past AQA paper. So we've got triangle ACD. So that's the larger triangle here. And then we've got an equilateral triangle BCD. So we've got two triangles joined together. And we're being asked to work out the size of angle X down here. So this is a really good example of a multi-step angle problem where you've got to apply some different rules to this problem. So pause your video and have a go at this one. Okay, so if we take a look at this then, our starting point here is going to be this equilateral triangle. So we said earlier that the angles on an equilateral triangle are always 60 degrees. So these ones are going to be 60. And then there's 2 points we can go from then onwards. There's kind of two ways of doing this. I'll show you this one first. So here we've got angles on a straight line. So here we've got this angle and the 60 degrees. That should add up to 180, because remember, angles on a straight line always add up to 180 as well. So if you take that 60 away from 180, we know that that's 120. If we add together those two that we already know, we get 140. So when we add those two away, and we can take 180 away from, say 140 away from 180, and we will then figure out that this angle here is 40 degrees. Another way of proving this, if you look at the just bigger triangle, the triangle ACD, we've got 80 degrees here if we combine that 60 and 20. So we can add that to the 40, add that to the 60, and that would give us 180 degrees as well. So you can do it with those angles. You didn't need to necessarily use your angles on a straight line rule, but it's okay if you did. Okay, let's look at one final one then. So we've got this BCD here. So BCD is a straight line. So it's important, if they're telling you something's a straight line, it will be important to answer the question. Triangle ABC is equilateral. This is the one on the left. And we're being told that CE, so this side here, is equal to DE. So all of these facts are going to be important in terms of trying to figure out this angle X. So I want you to now pause your video and have a go at this one. Okay, let's have a look then. So first of all, I'm going to deal with this equilateral one. So I know this is 60. A little bit for a tip for you, by the way, do what I'm doing here. So in the exam, when you've got your diagrams, write on them. When you start to figure out the angles, write them on the diagram, because that will get you marks if you've got the correct angles. Now, if we look at this triangle here, if we take that 28 away from 180, we're going to have 152. And then 152 divided by 2 will give you 76. So both of those base angles are going to be 76 degrees, because remember, base angles in an isosceles triangle are equal. And if we look at here, this straight line, the angle is on the straight line here, that's 60 and the 76. So if we add those together, we've got 136 already accounted for out of our 180. If we then take that off, that will give us an angle that's left of 44 degrees for X. Okay, so thank you very much for listening. Please hit subscribe. There'll be loads more videos appearing over the next few months. I hope this has been useful. So thanks very much. Bye bye.